Standing at the base of a 60-foot stone wall, you are carrying 80 pounds of equipment while arrows descend from the battlements. Every angle of the masonry in front of you is calculated to ensure you do not survive the climb. Popular depictions often present castles as static, passive barriers, fortified houses where royalty simply waited for a siege to end. In reality, medieval architects were military strategists who used stone to dictate the movement of an entire army. They exploited the laws of gravity and the constraints of human anatomy to multiply the effectiveness of a small garrison. To see how these defenses functioned under pressure, we will simulate a step-by-step assault, testing these layers of defense from the outer perimeter to the inner keep. A castle's true effectiveness lies in its ability to force an attacker into a gauntlet of mathematical certainties. Once you enter the kill zone, the environment decides your fate. A siege typically begins with a blockade. Attackers encircle the fortress and wait for starvation or dehydration to weaken the defenders. Castle engineers mitigated this by sinking wells hundreds of feet through solid rock. This provided a secure internal water supply that allowed a garrison to endure for months or even years. When time runs out, the attackers must close the distance. They use mobile wooden sheds to shield workers while they dump earth and brushwood into the moat to create a path for heavy equipment. This cross-section shows the mathematical relationship between wall height and moat width. A moat placed exactly 60 feet from the base of the wall forces an army to linger in the path of these overlapping arrow trajectories, while sitting just far enough away to prevent them from digging tunnels to collapse the foundation. To counter the heavy bombardment of trebuchets like this one, engineers built the interior chambers with thick, curved stone vaulting. This masonry was designed to distribute the impact of massive stones and remained immune to the fire arrows that would consume a wooden structure. Every element of the outer perimeter was designed to control the enemy's physical position, turning the landscape itself into a defensive tool. If attackers breach the gate, they surge into the Barbican, a narrow, fortified corridor specifically designed as a choke point. As the soldiers enter, a heavy iron portcullis drops behind them, instantly locking them in a stone tunnel with no forward path and no way to retreat. At this moment, the ceiling above them opens. Defenders on the floor above activate murder holes positioned directly over the trapped men. While often associated with boiling oil, these holes were typically used to drop heavy stones, scalding water, or heated sand. Because sand is granular, it easily infiltrates the joints of plate armor, burning the skin underneath. From this perspective inside the wall, a defender is nearly invisible behind 8 feet of stone. The internal flare of the arrow slit allows the archer to track and shoot targets across a wide field of fire while remaining protected from return fire. The gatehouse functions as a calibrated slaughterhouse, neutralizing an army's superior numbers by forcing them into an inescapable trap. Attackers who scale the first wall find themselves facing a concentric design. They are trapped in the lists, the open ground between 2 separate rings of massive fortifications. From this position, they face a lethal crossfire. Defenders on the taller inner wall can fire over the heads of their comrades on the outer wall, doubling the density of projectiles in the kill zone. If the surviving attackers reach the keep, the final self-contained fortress, their only path upward is the staircase. This overhead diagram shows how the spiral staircase exploits handedness. For a right-handed attacker ascending, the central pillar jams their sword arm, forcing short, ineffective stabs. The defender moving downward has their arm on the outside curve, granting total freedom for wide overhead strikes. Even when the walls are lost, the architecture forces the enemy into asymmetric combat, where spatial geometry decides the winner. By the late 13th century, concentric castles stood as the peak of medieval fortification, designed to resist human muscle and wooden siege engines for months at a time. The introduction of gunpowder introduced a destructive force that stone walls could no longer absorb. During the 1453 siege of Constantinople, Ottoman forces used massive cannons to shatter walls that had remained impenetrable for 1,000 years. Architects responded by abandoning towering walls in favor of the star fort. These low, wide earthen structures were designed to deflect and absorb high-velocity iron shot, rather than provide an elevated platform for archers. Gunpowder weapons turned a castle's defining strength, its towering height, into its primary vulnerability. The technological shift made the traditional fortress obsolete, ending the era of medieval siege warfare.